Okay, let's start this now. So you can see that we have three capacitors which are connected in the circuit as shown in the figure. Not three capacitors, yeah, 2 microfarad, 3 microfarad, and 4 microfarad. Now the question is, what is the charge on the capacitor B, which is the 3 microfarad capacitor? So what's the step one? These two capacitors are connected in parallel, yes. So I'm just going to redraw the circuit. This is the battery. This is the capacitor A. This is another battery. And now these two capacitors have become one capacitor. I've replaced it with its effective capacitance. So 3 and 4 in parallel will give you 3 plus 4, 7 microfarad. Okay. Now, this can be solved like how you will solve a series resistive network. Okay. So on the left hand side, we'll write the equation here. Kirchhoff's voltage law. On the left hand side, we are going to write the EMF. Okay. So what can be the polarity on 7 and 6 are there? Are they supporting each other or opposing each other? If they are, should I add their polarities or should I subtract them?
Add, sir.
See, when we go in this direction, right? You first see a minus, then a plus. So here it is plus 7. Then when you go here, right, it is plus first and minus second. Therefore, it is a decrease in potential. So what do you do?
Minus.
Minus. Yeah, so it is not 7 plus 6. It is what?
7 minus.
Yes. Are you clear with this?
Yes, sir.
Yes, sir.
So it is 7 minus 6. So that will be the voltage provided by the battery. And that will be equal to, suppose if the voltage across the 2 microfarad is V1 and the voltage across the 7 microfarad is V2, then what will this supply voltage be equal to? The total voltage provided is equal to voltage consumed. Total voltage provided is 7 minus 6. Why is it minus? Because of the change in polarity. Instead of plus minus, if it had been minus plus, then it would be 7 plus 6. All right. Please respond.
Yes, sir.
Yes. Okay. So what is V1? What is the relationship between, if I have a capacitor whose charge is Q, whose capacitance is C, and the voltage across the capacitor is V, then what is the relation between all the three variables? Q is equal to CV. Or in other words, V is equal to Q by C. Okay. Because the two capacitors are going to be connected, this 2 microfarad and 7 microfarad are connected in series, both of them will have the same charge on them. So charge on this will be Q, this will also be having a same charge Q. Therefore, you understand Q is equal to CV, so V is equal to Q divided by C. So V1 I can write it as Q divided by C1. What is C1? 2 microfarad. And V2 is nothing but Q divided by 7 microfarad. 7 minus 6 is 1. So this, when we solve, we will get the value of Q. Okay. That's our first step. So let's find out what is the value of Q here. So LCM is 14. 7Q plus 2Q. So it's going to be 9Q. 9Q is equal to 1. Or in other words, Q is going to be equal to 14 by 9 microcoulomb. That is going to be the total charge. Okay. Now from this, can we find V2? Can you tell me what is V2 going to be? You know the voltage, you know the capacitance, you know the charge. So what is V2? V2 will be charge divided by C2. So charge is 14 by 9. divided by C2. What is C2? 7 microfarad.
2 by 9.
Yes. So it is going to be 2 by 9. 2 by 9 volts. So the voltage across the 7 microfarad capacitor, what is it going to be? 2 by 9 volts. In fact, the 7 microfarad is nothing but the combination of 3 microfarad and 4 microfarad. So if you see this voltage, the voltage between the 2 points here, let's say we call this point as, let's say X and this point as Y. Then the voltage between X and Y is 2 by 9 volts. So these 2 points are nothing but X and Y. Right? So that voltage is going to be, we already got it. What is the value?
2 by 9.
2 by 9 volts. Now we need to find the charge on the capacitor B. So capacitor B, we need to find the charge. So what is charge on the capacitor B? Charge is given by C into V. So what are the capacitance of the capacitor B? 3 microfarad. And what is the voltage across this? 2 by 9 volts. This gets cancelled. Therefore, your charge is going to be 2 divided by 3 microcoulomb. So your charge on the capacitor B is 2 by 3 microcoulomb. So which option is correct? Second option. Are you clear with this?
Yes, sir.
Yes.
Yes, sir.
Okay. Please go through it once. I'll give you a minute for taking it down. Can Rahil, can you explain once what I have done so far? How do you start? Yeah, go ahead.
Sir, so first we take B and C, sir, and since they are connected in parallel, we add them, sir, the
Yes.
capacitance, so it becomes 7.
Yes.
After that, when we do the voltage, sir, so first it goes plus, then it goes minus. So V1 plus V2 it becomes 7 minus 6. It will be 1, sir. So to find the charge, sir, total voltage is 1. So Q by 2 plus Q by 7, sir, it will be 9 Q by 14. So
What is it? Q by 2?
Q by 2 is the charge for
V1.
voltage for A, sir. So Q by 2.
No,
And,
voltage is nothing but charge divided by charge divided by what?
C, sir.
Yeah, capacitance, exactly. Right? Okay,
Yep.
fine. So Q by 2 refers to V1, Q by 7 refers to V2. Voltage across the same capacitor, yes.
And
why did you say take same Q?
so because charge is same.
How do you say that?
Because charge is same in series connection.
Yes, these two capacitors are connected in
Series.
series. Yes, okay.
So when we add that, sir, we get Q is equal to 14 by 9. So to find the voltage in B, sir, we do V2 is equal to Q by C2. So when we calculate that, we get 2 by 9 V.
2 by 9 volt. We are still in the new circuit. That is this circuit. This circuit.
So in the next thing we get Q3. So C by V. C is 3 and CV, sir. So
okay, one minute. Just be a little slow. So what is this V2? This V2 2 by 9 volts is the voltage across this capacitor, correct?
Yes, sir.
Yes, but that is also the voltage across this 3 microfarad or 4 microfarad because both of them are connected in parallel. In parallel, the voltage is same.
Yes, sir.
Okay, that's why the voltage that we got for the 7 microfarad is the same as the voltage for the 3 microfarad also.
Yes, sir.
Yes, so that is 2 by 9. So now we want the charge on the 3 microfarad capacitor. So charge will be given by, now go ahead.
Charge is C into V, capacitance into voltage. So that will
When you tell
be
that, please tell which capacitors into which voltage. Which charge we are
capa
talking about.
3 what's it? Capacitance of B and voltage is same across B and C, sir. So
Yes,
2 by 9 and 3 is the capacitance for B. So when we calculate it, we get 2 by 3 microfarad.
like a coulomb charge.
Charge coulomb. So micro.
Okay, ma. Good, fine. Okay. And that clarity must be there. Is it clear, Rahil?
Yes, sir.
Yes. Is it clear, Alvin, Rebecca, and Akila?
Yes, sir.
Yeah. Please be fully involved and fully be responding. Yes. Okay. Good.
Yes, sir.
Yeah. Okay. Let's go to the next question now. Oh, fine. Let's go to this question now. Okay. So now we have 3 capacitors. Is my voice audible?
Yes, sir.
Okay. Just in case if it's feeble or anything, let me know.
Yes, sir.
Okay. Fine. Now 3 capacitors are connected as shown in the figure. What is the charge on the capacitor C1? Okay. Let's call these as C1. Let's say this is C3. This is C2. Okay. Okay, ma. So we need to find out what is the charge on the capacitor C1. Okay. Now, how you can solve this question is, okay, suppose if I cut it vertically, right? If you just see, the right hand side is a mirror image of the left hand side, is it not?
Yes, sir.
Yes, sir.
So in that case, there will be symmetry, okay? You have 2 batteries, right? 6 volts and 6 volts, correct?
Yes, sir.
Yes, okay. Now, what happens is, because of the symmetry, the charge provided by both the 6 volt batteries will be same. Suppose the 6 volt battery is providing a charge capital Q, then the right side battery will also be providing a charge Q. Is it clear?
Yes, sir.
Yes, sir.
Therefore,
Yes.
the charge on C1, let's say, is Q. Then the charge on C2 will also be Q. All right? Okay. Now, just like how you will do for a resistive network. Suppose I have a resistor here. Okay, suppose if this is providing a current I, this battery is providing a current I. Both these currents will come here and join and flow into this branch as how much? Please respond. You have current I coming here, current I coming here. Both of them will combine here and it will flow as I plus I2I. Okay.
Yes, sir.
Yes, sir.
Similarly, what is going to happen here is you have capital Q charge provided by battery 1, let's say 6 volts. Another battery is also providing a charge Q. Then at the junction, what will happen is, just like how the currents are adding, so on this branch, which let me call it as BD. On this branch, the charge will be Q plus Q, which will be 2Q. Are you able to understand?
Yes, sir.
Yes.
Yes, sir.
Okay, this is step 1. Okay. Now, step 2 is you have 2 loops here. One is the loop A, B, D, A. Okay. Another loop is D, Y, X, B. Okay. You take one loop because there is only one unknown variable in this question. The only unknown variable is Q. Okay. So that is to be found. That can be very easily found. Just observe here. Let us take one loop AB. I'm sorry. Let me call this a schema. Okay, fine. So A, B, C, D, A. Let's say we take that loop. Okay. Let's say we take the loop A, B, C, D, A. So in that loop, how many batteries you are having? In that loop alone? One battery, right? The 6-volt battery, which is here. Okay. So on the left hand side, we will write the EMF or the battery voltage. And on the right hand side, we will write down the voltages of the components. Okay. So let us say the voltage of the capacitor C1 is V1 and the voltage of the capacitor C3 is V3, let us say. Then in this loop, which I'm talking about, A, B, C, D, A, how many elements are there? How many passive and active components are there? Your active component is the battery. Passive components are like capacitors, resistors, etc. So in that loop, A, B, C, D, A, how many components are there?
3.
3 are there. Very good. So one is the battery, which is the active component. 6 volts battery is there. Then 2 capacitors are there. What are the 2 capacitors?
C1 and C2.
C1 and
C2. C3.
C1 and C3. Correct. 2 microfarad and 4 microfarad are there. What are their respective voltages?
2 and 4.
No. I asked the voltage.
Oh, the voltage 6 and
No. V1 and V3.
Okay, V1 and V3.
Yes.
Okay, sir.
Fine. Okay. So now let's go write that. So on the left hand side, I'm going to write the EMF. So what is the EMF value?
6
volts is equal to what is the voltages across the 2 capacitors in the loop?
V1 plus V3.
Yes, so this is V1 plus V3. So all these 3 sums which we are discussing now are all similar. Okay. So V1 plus V3 is equal to 6 volts. Okay. Now go to this. Okay. So you have all these 3 variables here, right? So what is the relationship between them? You have Q, C1 and V1. What is the relationship between them?
Q is equal to CV.
Yes, ma'am. So Q is equal to C1 into V1. So we want V1 here. So what will be V1?
Q by 2.
Q by C1.
Yeah, Q by C1, which is nothing but Q by 2 microfarad. Correct. Then what about similarly? Can you tell me for V3?
Q by 4.
Is it Q by 4? Is it Q by 4?
No, 2Q.
Yes.
2Q by 4.
2Q by 4. The charge on the capacitor C3 is 2Q. Very good. So it is 2Q by 4. That's all. Yes. So now 6 is equal to Q by 2 plus 2Q by 4 is nothing but Q by 2 itself. Correct?
Yes, sir.
Yes, sir.
Q by 2 plus Q by 2 is Q.
2Q by 2.
Yes, 2Q by 2 or Q itself. So Q is equal to 6. Yes or no?
Yes, sir.
It is microfarad because here it is what? Micro. So this is Q by 1 micro. So Q will be equal to 6 microfarad. I'm sorry. 6 micro coulomb. So which is the answer?
A.
A. Because the charge on the capacitor C1 is 6 microcoulomb. Charge on the capacitor C2 is also 6 microcoulomb. Charge on the capacitor C3, 4 microfarad will be what?
2Q.
2Q. So that will be 12 microcoulomb. Clear?
Yes, sir.
Yes. So is this clear to you? I'll give you a minute to note it down. So these 3 questions, I want you to focus more and, do it once or twice so that you understand how the loop equations are written.
Yes, sir.
Okay, yeah. Once you are ready, let me know. We'll go to the next question.
Done, sir.
Done? Okay, sure. We'll go to the next question now. So let's look into the 25th question. Okay. For section AB of the circuit shown in the figure, C1 is 1 microfarad, C2 is 2 microfarad, and E is 10 volt. The potential difference between A and B is minus 10 volts. Then what will be the charge on the capacitor C1? Okay. So for our understanding, what we can do is we can connect A and B with a battery because there is a potential difference. Now VA minus VB is minus 10. Then what will be VB minus VA?
10.
10, yes, plus 10. So VB minus VA is plus 10, correct? So can you tell me which is higher potential, VB or VA?
VB.
VB, exactly. So the positive terminal of the battery I should put towards B, and the negative terminal of the battery I should put towards A side.
A.
So what is the voltage? 10 volt.
volts.
Yeah. Okay. And what is the value of E? E is also 10 volt. And the capacitor C1 is 1 microfarad. And capacitor C2 is 2 microfarad. So the question is very simple. You just have to find the charge. And all the 4 components, how many components are there? 4 components are there. They form a single loop. All right. So the charge in the entire loop will be the same. So charge on capacitor C1 will be Q. Charge on capacitor C2 will also be Q. Therefore, let's say the voltage here is V1, the voltage here is V2. Now, can you tell me what is going to be the loop equation, Kirchhoff's law equation, right? On the left hand side, you should write the EMFs. On the right hand side, you should write the voltages. So can you tell me? Please respond. If you yes, go ahead now. Tell me.
The sum of the potential difference in a closed loop is 0.
Or in other words, the EMF, sum of EMFs is equal to the voltage drops across the capacitors.
Okay, sir.
So what is it going to be? On the left hand side, you're going to write the EMFs. So what are the EMFs? What are the batteries?
10 volts.
10 and 10. 2 10s are there, correct or not?
Yes, sir.
And if you see, they are supporting each other, which means if I traverse in the anti-clockwise direction, right? Then I see the negative terminal first and then the positive terminal. So it's a plus 10 or a minus 10?
Minus 10.
I'm going in the anti-clockwise direction. First I'm seeing negative
no,
and then the positive. So there is an increase in potential or decrease in potential?
Oh, there's an increase.
Increase, correct? Because minus to plus, increase.
Yes, sir.
So should I put a plus 10 or a minus 10?
Plus 10.
On the top one. What about the bottom one?
Minus 10.
Minus 10.
No. Look at it carefully. It's going. I'm going in the anti-clockwise.
Oh,
direction.
no, plus 10 only, sir.
First I'm seeing minus and then I'm seeing plus. So what is it?
Plus 10.
Yeah, plus 10. So what is it? Okay. 20. So that's going to be the total voltage provided by the battery. That will be equal to the voltage drops across the other components. What are the other components? Yeah, tell me.
C1 and C2.
Yes, C1 and C2 are the two components. So what will be the voltage drops? I'll return it right.
Oh, V1 plus
Yeah.
V2.
Yes, that's what I want you to tell me. Okay, fine. Right. So what is the total voltage here on the left hand side? 20, and that's equal to V1 plus V2. Okay. Now, can you tell me the relationship between all these three variables?
Q is equal to CV.
Yes, Q is equal to CV. So Q is equal to 1 microfarad into what? V1. And what about this here? The same charge, because both are in series, will be equal to
2 microfarad into V2.
yes, 2 microfarad into V2. Exactly. So from this, can you tell me what is V1? No. See, V1 plus V2 is 20. So V1 cannot be 20, right?
Okay.
Okay. I'm just asking you to rearrange this and tell me, that's all. What is V1?
Q by 1.
Yeah, Q by 1 microfarad, right? Okay. What is V2?
Q by 2 microfarad.
Yeah. Okay, so 20 will be equal to. So instead of V1, I'm writing Q by 1 microfarad. V2, we are writing Q by 2 microfarad. So last 4 questions, we are doing exactly the same thing. Okay. Are you able to observe?
Yes, sir.
Yes. You need to get comfortable with this very quickly. So what it means is, one of the sums was done in the last class itself. So you need to review them. Please do review all these 4 questions twice, thrice, 4 times. Okay. So that you are clear with this fundamentally. You must give these answers very quickly. Okay.
Yes, sir.
Yes. Okay. First time you can take time to learn, no problem. But once it is taught, then that's the time you have to press the accelerator and learn faster. I told you, right? One success formula I've told you. It is what you learn after you know it all that counts. So once you know the subject, that's when you should learn more. Okay.
Yes, sir.
Yeah, don't leave it like that. Okay. So fine. So when you take LCM, what does it become? 1.5, right? So the LCM will be, denominator is 2 micro. Numerator will be 2 plus 1. So it will be 3.
3Q.
Yeah, 3Q is equal to
20.
yes. So 3Q will be
20 into 2. Q
20
is
into
equal
2
to
microcoulomb. So that will be how much? 40. So what is Q equal to?
40 by 3.
Exactly. 40 by 3 microcoulomb. So this is done. Is it clear?
Yes, sir.
Yes. Yeah. Please make a note of it, and then once you're done, let me know.
Done, sir.
Done now. Okay. And any doubt in between, please don't hesitate to stop me and ask me again.
Yeah, sir, sure.
Okay, yeah. So let's go to the next question now. Okay, we have 26th question. Okay, a capacitor of capacitance 1 microfarad is charged to 30 volt and the battery is then disconnected. Okay, so let's look at the first point and then understand it. Okay, so first what you're doing is you're taking a capacitor. What is its capacitance? 1 microfarad. It is connected to a battery. Let's say it's allowed to get charged up to 30 volts. Fine. So now, can you tell me what will be the charge on this capacitor? What is the relation between charge, capacitance, and voltage? Please respond. Charge, capacitance, and voltage. What is the relationship? QCV. What is the relationship?
Oh, Q is equal to CV.
Yeah, that's what I was asking with terms. Charge, capacitance, and voltage. Okay, fine. So Q is equal to CV. Okay. So what is the capacitance here?
1
1 microfarad. 1 microfarad. And what is the voltage?
30.
30.
30 volt. Good. Okay, fine. So the charge will be equal to 30 microcoulomb. Is this clear?
Yes, sir.
Yes,
Yes.
sir.
Fine. So now what we are going to do is battery is going to be disconnected. Fine. When the battery is disconnected, what will happen is based on the conservation of charges, the charge will still remain what? 30 microcoulomb. Clear? Please make note of all these things. These are very important. When battery is disconnected, so here you know capacitor can store charges. Correct? So if you connect a resistor to a battery, suppose 50 volt battery is there and 10 ohm resistance is there, then the current will be given by V by R. 50 divided by 10 will be 5 amperes, right? Suppose if I have a resistor connected to a battery, let's say the battery is 50 volt and the resistance is 10 ohms, then you know a current is equal to what? 50 by 10, which is 5 ampere, will flow in the circuit only as long as the battery is there. If you remove the battery, how much will be the current through the resistor? 0, correct?
Yes, sir.
But that's not the case in capacitor. In case of a capacitor, the moment you charge it to a charge of 30 microcoulomb, let us say, right? And then even if you disconnect the battery, the charge on the capacitor will still remain intact. Is that clear?
Yes, sir.
That's
Yes,
important to know, right? So when battery is disconnected, the charge Q on the capacitor remains. Remains on the capacitor itself. Is it clear to you?
Yes, sir.
Yes, sir.
Yes. Okay, great. So now let us see what is. Let's read the next part of the question. Is it clear? Is the first part clear to you?
Yes, sir.
Yeah. So anybody can explain the first part what we did and tell me. Yes, Alvin, you can go ahead.
Okay, sir. So, in this circuit, the capacitance of the circuit is 1 microfarad, and the voltage is 30 volts, which is connected to a battery. So the total charge on the circuit will be 30 microcoulomb. So once the battery is removed in the capacitor, the charge remains the same.
Yes. And in the beginning when you said, right, so capacitor got its voltage became 30 volt only because it was connected to the battery. Okay.
Okay, sir.
Yeah. Okay. Okay. Okay, now let's look at the second part of the question, which is, it is then connected across an uncharged 2 microfarad capacitor. Okay. Okay, now I'm going to connect this capacitor, which is here. What is the charge on this capacitor?
30
microcoulomb.
Yes, this capacitor, I'm going to now connect it across another capacitor, which is uncharged. But what is the capacitance of that?
2
microfarad. Yes, ma'am, correct. So now I'm going to take this capacitor, which is having a charge of 30 microcoulomb. This I am going to connect it to another capacitor, correct? So what is the capacitance of our capacitor? First capacitor, 1 microfarad. Let me call it a C1. Let's say this is Q1. Okay. So the charge on the first capacitor is 30 microcoulomb and the capacitance of the first capacitor is 1 microfarad. Now this is connected to another capacitor. What is the charge on this capacitor? Is it charged or uncharged?
Uncharged.
Uncharged. So it is 0. And what is the capacitance of this? Given as 2 microfarad, correct? Uncharged 2 microfarad capacitor. Is it clear?
Yes, sir.
Okay, this is the scenario now, new scenario. Now, the moment this happens, right, one capacitor is charged, another capacitor is not charged. What will happen is when you connect both of them, the one which is charged will start sharing its charge with the other one. Are you clear?
Yes, sir.
Yes,
Okay.
sir.
Now, how long will they share the charge? They will share the charge until their potentials become equal. So let me write it here. This is also important. Charge sharing happens between the two capacitors until potential on both of them potential difference on both of them become equal. You call it as a common potential. Okay. So can somebody repeat this point, what we are talking? Yes, go ahead, Rahil. Can you try? Or can Alvin, can you try? One of you have to answer, right? Otherwise, we cannot proceed. If you did not understand, tell me, then I'll repeat again.
Charge sharing happens until potential difference on both of them become equal.
Yes, ma'am. So what is the charge on the first capacitor?
30 microfarad.
30 microcoulomb. Charge is unit is coulomb.
Got
Okay. Fine. What is the charge on the second capacitor?
0.
0, right? Now, one is having charge, another is not having charge. So even when they are both having charge, but they are having different charges, then charge sharing can happen. Till what point will the charge sharing happen? It will happen only until both of them reach the
potential
Same
difference.
potential difference. Is it clear?
Yes, sir.
Okay, ma. Okay, fine. Because both of them are going to have the same potential difference, you can consider these two capacitors to be connected in parallel, correct? Only parallel circuits have the same capacitance, correct?
Yes, sir.
Yes, sir.
Not same capacitance, I'm sorry, same potential difference. Yes?
Yes, sir.
Yes, sir.
Yes, okay, fine. So the two capacitors are connected in parallel. So what is the effective capacitance? Can you tell me the effective capacitance? They both are connected in parallel. Go ahead.
CP is equals to C1 plus C2, sir.
C1 plus C2, correct, ma? Correct. So what is it going to be? 1 plus 2.
3 microfarad.
3 microfarad, exactly. So the effective capacitance is 3 microfarad. So I'll redraw the circuit now. So C effective is going to be 3 microfarad. And what is the total charge in the system? What is the total charge in the system? Here it is 30 and then it is 0 here. So what is the total charge? One is having 30, another is having 0. So total is what? 30 plus 0. How much?
30.
30. Okay. So total charge in the system is 30 microcoulomb and the total capacitance is 3 microfarad. Are you clear?
Yes, sir.
Yes. Now can you predict what is the common potential between them? You know Q, you know C. Can you tell me what is V? You know the formula connecting Q, C, V. What is it?
Q is equals to CV.
Yes, ma. Yes, yes. Confidently say Q is equal to CV. No, don't ask it as a question. Q is equal to CV, right? So what is V equal to?
C
Q
by
by
Q.
C.
Yeah, Q by C.
Q by C.
Yes. So what is your Q?
30
30
microcoulomb.
microcoulomb. So what is your C?
3 microfarad.
3 microfarad. Micro will cancel, okay? So 30 divided by 3. So what is it?
10.
Volts. So the common potential difference between the two capacitors is going to be 10 volts. So is that what is asked? What is asked? Energy lost by the system is asked. Okay, we will come to that. Okay. So what is the common potential now?
10. 10
10
volts.
volt. Is it clear so far?
Yes, sir.
Okay,
Yes,
I want somebody to explain the whole thing so far. It's an important concept. Start from here. Even if you make mistakes, it's fine, but just explain so that I know you understand. Yes, go ahead, Rebecca. Try it.
Yes, sir. So we have a capacitor of capacitance which is 1 microcoulomb and volt is 30.
No, no,
Which is
capacitance should be 1 microfarad. Only charge you should say coulomb.
Okay, okay. So next we'll be finding the relation between QCV, which is Q is equals to C into V, and we'll find the charge. Next. So first charge Q1 is 3 microcoulomb. Next, when charge is disconnected, Q remains 1 sec.
Charge is 30 microcoulomb. When battery is disconnected,
Battery is disconnected. Capacitance remains the same.
not the capacitance, ma. Capacitance will always remain the same. The charge on the capacitor will be there.
Okay.
Charge, suppose whatever it is, charge that is deposited will still remain on the capacitor itself.
Okay.
Okay, how much is the charge?
30
microcoulomb. Yes.
coulomb. Yes, sir.
Okay, even after disconnecting the battery, the charge on the capacitor plates will remain intact, remain same. Yes.
Yes, sir.
Okay, now what is the next thing you are doing? It is then connected
to a uncharged capacitor.
of capacitance 2 microfarad, correct?
Microfarad.
Okay, we'll come to that. Yes, go ahead now. Now explain this part. So you're taking a capacitor here, which is charged to how much? 30 microcoulomb.
30
And the
microcoulomb,
capacitance is 1 microfarad. That you're connecting with another capacitor, which is
which charge is 0, like it
because
is
uncharged.
uncharged.
Yes. And what is the capacitance?
2 microfarad.
Yes. Whenever you do this, what will start happening?
Like the charged coulomb starts to share with the
The
uncharged,
charged capacitor will start sharing its charge with the other one. Yes.
and till the potential difference becomes the same.
Yes.
It will
On both the
share.
capacitors. Yes.
Yes, sir. So here
Both the capacitors, how they are connected?
they are connected in parallel.
Yes. So what will be the effective capacitance? That's the next thing.
Cp is equals to C1 plus C2.
Yes.
Huh.
So you will get 1 plus 2, which is
3 microfarad.
yes, correct. So you found the effective capacitance. You made
Yes.
these two capacitors into one capacitor. And what is the capacitance?
3 microfarad.
3 microfarad. What is the charge? Total charge?
Total charge is 30 microcoulomb. So
Yeah, because 30 plus 0. Suppose if this was 10,
yes.
the second one, if it was 10 microcoulomb, then the total charge will be 40 microcoulomb, correct?
Yes, sir.
If the second capacitor was like minus 10 microcoulomb, then it will be 30 plus minus 10, it will be 20 microcoulomb, right? Like that, correct?
Yes, yes.
So this total charge is nothing but the addition of the two charges.
Yes, sir.
Okay, this is the total charge 30 microcoulomb. Now you know the total charge and you know the total capacitance. So you can find the total voltage, the common voltage.
Yes, sir.
So what is yeah.
Q is equals to CV. So if
Yes.
we are finding the voltage, it will take like Q by C.
Yes,
So we'll take the charge by the capacitance.
very good.
Cancel them, we'll get 10 volts. So
Yes, so
30 by
so-
3, 10 volts.
yes, so 10 volts. What is the 10 volts? 10 volts is called the
The total voltage.
common voltage. You call it as
Yes.
common potential or common voltage. Okay,
Yes, sir.
this is the term given to them. Okay, fine. In this process of charge sharing, some energy is lost in the form of heat. Okay, because the charge will move through the wire, right?
Yes, sir.
It is a current. It is a current which is flowing, right? So current, whenever it flows in the wire, it produces heat energy. I square R. I square RT is the heat energy loss or power loss. Okay.
Yes, sir.
So what is the energy lost by the system? That is the question. The question is not to find the common potential. Common potential is only part of it. All these what we have found step by step are only part of the answers, right? So now we need to find out the energy lost by the system, correct?
Yes, sir.
Okay, fine. Of course, once we learned all these things, I will just give you some formula, because simply if I give you the formula, your final formula, you will not know for which question you should use and which question you should not. Clear?
Yes, sir.
So I'm teaching the proper process of finding out the answer. Okay. Then later, once you become experts, then I can give you just the formula quickly. For this type, you use this one. For the other type, you use different ones. And you'll be able to understand. Okay.
Yes, sir.
Yes.
Okay. So now let's find out the last step, which is finding out the loss in energy. So first, what was there? First, you had one capacitor, which was connected to a battery. What was the charge on this? 30 microcoulomb. And what was the capacitance of this?
1 micro.
1 microfarad. And what was the voltage to which it was connected?
30 volt.
Yeah, in this case, there would have been an energy, right? That is the initial energy. So what is the expression for energy stored in the capacitor? Do you remember? It is given by half CV square. Okay, can you repeat with me? What is the energy stored in a capacitor?
Half CV square.
Half CV square.
Yes.
Square.
It can also be written as half Q into V, because what is Q? What is Q?
The charge.
Charge.
Correct. What is the formula? What is the connection between Q, C, and V?
Q is equal to CV.
CV.
Yeah, if you put Q is equal to CV, what you will get? You will get back this equation.
Yes, sir.
That's why it is half QV. That is one more way of writing it. There is one more way of writing it. Please make a note of it, and this must be remembered, okay? Another way of writing it is Q square by C. So Q square by 2C in fact. Because what is Q? CV, right?
Yes, sir.
Yes, sir.
So the Q square will become C square V square divided by C. One C will cancel, you'll get back half CV square. Are you clear?
Yes, sir.
Yes, sir.
Depending on the situation, you'll be using one of them, okay? So you must keep it in your mind, right? When I say energy stored in a capacitor, you must, it must be in your fingertips. You must say it is half CV square, or immediately you must say it's half QV, or you can say it's Q square by 2C. Clear?
Yes, sir.
Yes. So
Yes, sir.
can you say now quickly, each one of you, all the three formula? What is the energy stored in a capacitor, Rebecca?
1/2 CV square.
Square, half CV square. Go ahead like that.
Full, sir.
Full, yeah.
Yeah. Next, half by QV.
No,
Next,
half QV.
half QV and half Q square by C.
Yes. The last one alone, you can say Q square by 2C also if you want.
Okay, sir.
Okay, yeah. Rahil, can you tell me?
Half CV square.
What is it?
Half
What is it?
QV.
Energy stored in a capacitor is like that, you say.
Energy stored in a capacitor is half CV square, half Q into V, or half Q square by C.
Yes. Okay. Go ahead, Alvin.
So the energy stored in a capacitor is equal to half CV square, which is also equal to half QV, which is equal to Q square by 2C.
Yes. Yes, Akila, go ahead.
The energy stored in capacitor half CV square is equals to half QV is equals to half Q square by C.
Yes. Okay, you must keep it in your fingertips. Good. Fine. Now, from this we can find out when we have C, we have V, everything is there. We can use any one of the formula and find out. Okay. So let's use. So what is the initial energy? Can you tell me? Initial energy is half into C. What is C?
1
One.
microfarad.
1 microfarad into what is V?
30.
30. Very good. 30 square. Clear? CV square. Correct?
Yes, sir.
Yes, sir.
Okay. So this will be half into 1 micro. 330 square is 900. So what is 900 divided by 2?
450.
450. So it will be 450 micro. Unit is joules. Is it clear? This is the initial energy stored in the capacitor. Okay?
Yes, sir.
Fine. Now I'm going to give you time to note down all these things. Okay? So let me give you some time. Take down all these things. Now we are just 2 steps away. We just want to find out what is the new energy. Now we found the old initial energy. Now we'll find the final energy. Then we have to just find the difference. That will complete the question. So please take it down. Once you're done with this one, tell me, I'll move the slide.
Done, sir.
Done, ma? I'll move to the next part. Yeah, note down this part also.
Done, sir.
Okay. Great.
Done, sir.
Very good. Okay, now we are just left with finding the final energy. Before that, just look at the final way how the capacitance is, right? Although there are two capacitors, we have made it into effective capacitance, right? So what is the charge on the capacitance?
30
30.
30 microcoulomb. What is the total capacitance?
3 microfarad,
And what is the common potential?
10 volts.
10 volts. Very good, very good, very good. Okay, I'm just going to write them here. Okay, I'm just going to draw it here. So we have the final capacitor. Of course, it's not one capacitor, two capacitors in parallel, correct? But I'm just writing the effective values. So what is the effective capacitance now?
3 microfarad,
3 microfarad. And what is the common potential?
10 volts.
10 volts. And what is the charge?
30 microcoulomb.
The same charge shows there, 30 micro, correct. So this is the parameter. So now can we find the energy, final energy? What is the final energy?
Half by CV square.
Half into CV square, right? Clear?
Yes, sir.
So this is half into C effective. What is C effective?
3 microfarad,
3 micro. Now what is the common potential?
10 square.
10 square, exactly. So what is your UF, your final going to be equal to? 3 into 10 square. 10 square is 100. 3 into 100 is 300. 300 divided by 2. What is it? 150 microjoules. Yes, clear? This is 100. 3 into 100 is 300. 300 divided by 2 is how much? 150. Clear?
Yes, sir.
Yes, sir.
Yes, okay. So as madam was also telling, do not use calculators for your CET class, right? So then that will become a practice and it will not help you while you're solving the actual sums, right? In CET. Okay, so your final energy is 150 microjoules. What is the initial energy?
450.
Yes, so the loss in energy. Loss in energy is nothing but initially you had greater energy, now you are having lesser energy. So the difference is the loss. So initially you had 450 microjoules. Now you are only having 150 microjoules. So what is the difference? $300 microjoules. Clear?
Yes, sir.
Yes. So this is your answer. So let's see if we have the option here given the question. So what is the right answer?
First option.
First
Three.
option. Yes. Yes. So this is the final energy. So let me write it here. So final energy is stored in the capacitor. This is a loss in the energy. So can you take this down? Once you're done, just let me know, then we'll proceed to the next question. Are you done?
Done, sir.
Done, ma? Okay, great. Fine. So are you able to understand the whole flow?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. Who would like to explain it once quickly? Rahil, can you try? Whoever, I don't mind who is going to share. I just want it to be quickly done within about 2 minutes. Explain. Alvin, please go ahead.
Okay, sir. So,
Yeah.
like, shall I go at like a summary or should I explain in detail?
No detail, right? Just step by step. Yeah.
Okay, sir. So here we have a circuit with a battery of 30 volts and capacitance with 1 microfarad. So the volt of the capacitance will the charge of the capacitance will be 30 microcoulomb. So once the battery is disconnected, the charge of the capacitor remains the same, which
Yes.
is 30 microcoulomb.
Yes.
And then here,
The question says battery is then disconnected. It is then connected. This capacitor is then connected across an uncharged 2 microfarad capacitor.
yeah, sir.
Now,
So the after the battery is disconnected, the charge and the charge would be 30 and capacitance would be 1 microfarad.
capacitance will be always 1 microfarad.
Yeah, sir.
Yeah.
So it is connected to a capacitor with an uncharged capacitor. So the charge would be 0 and the capacitance would be 2 microfarad.
Yes.
And then the charge sharing the charge sharing happens until the potential difference of both the capacitors becomes 0.
Not
So-
0, equal.
Equal. I'm sorry. Yeah.
So the moment you connect it like this, then charge sharing will happen, right? And
Yes, sir.
the charge sharing will continue until the potential difference between both the capacitors become equal.
Equal.
Right. So now these two capacitors can be considered to be connected in parallel, right? So what will be the effective capacitance?
Effective capacitance is 3.
Yeah, now go ahead, continue.
And then we find the potential difference.
Yeah, what is the total charge on the capacitor?
Total charge is 30.
Because
30
it is
microcoulomb.
Q1 plus Q2, 30 plus 0 in this case.
30 plus 0 is 30.
Correct.
So we find the common potential by V is equal to Q by C.
Yes.
From Q is equal to CV. So 30 by 30 microcoulomb by 3 microfarad, which will give 10 volts.
Yes. So common potential is 10 volts. This is a
10
final
volts.
setup. Okay. Yeah.
Yes. And then now we find the energy stored in the circuit.
Initially and finally, what it is. Yeah.
Initially and finally. So the initial energy stored, we can calculate it with half CV square. So answer is 450 microjoule.
Yeah.
And the final energy stored is 150.
Yes.
So and then we find the difference between the initial and the final
To get the loss in energy.
to get the loss in energy.
Yes.
So finally the answer would come up to 30 microjoule.
300 microjoules.
300.
Yes, Alvin. Good. Very good. Very good. Excellent. Excellent. Yeah.
Thank
This
you.
is the level of understanding which is required. Okay. Good. Everybody, and you will go through these questions and at least 3-4 times. Okay.
Yes, sir.
Okay. Now the remaining questions are also, a few more questions are also based on the same concept on energy loss when two capacitors, when this happens. So let's do one or two more questions now. Okay. So can one of you read the question first? Yes, Rebecca, go ahead.
Yes. The energy stored in the charged capacitor is U. Another identical capacitor is connected parallel to the first capacitor after disconnecting the battery. Total energy stored in the system of these capacitors will finally be
Okay.
options.
Very good. So this question is very similar to the previous question. Here we are not finding the loss of energy, but we are only finding what? The energy stored in these capacitors finally. So final energy we need to find out, correct? And how is it related to the initial energy U? That's the question, okay? So let's draw the scenario and explain it. So first you have a capacitor. It is already what?
Charge.
Charged, yes. So which means a similar situation like previous case. So you must have had a battery. Let's say its voltage was V. Let's say the capacitance of our capacitor is C. Let's say it has given a charge Q. Then what will be the relation in QC and V?
Q is equals to CV.
Yes, ma. Okay. So this is charged capacitor, correct? Like this. Okay, fine. Now what you're going to do, you're going to disconnect the battery, correct? After disconnecting the battery. Can you see this?
Yes, sir.
Yes. Okay. So meanwhile, we'll also write what is the energies, what is the initial energy. You can use any one of the formulae, but you can say half CV square, correct? You all with me? Please respond.
Yes, sir.
Yes.
Yes.
Okay. Fine. Now I am disconnecting the battery. Even if I disconnect the battery, what will still remain?
The charge.
Very good. Very good. Very good. The charge will still remain as Q only. Okay. Capacitance anyways will be C. There is no doubt about it. Whether you connect the battery, don't connect the battery, nothing. Whether charge is there, charge is not there. Capacitance is the inherent quality of that, depending on the dimensions and everything. So that doesn't depend on potential or charge. Okay. Fine. So what is the charge on the capacitor? It is still Q. Are you clear?
Yes, sir.
Yes, sir.
Even after disconnecting the battery. Okay. This is the second scenario where you disconnected the battery, but still the charge is Q. Okay. Now what's going to happen? You're going to connect another identical capacitor is connected parallel to the first capacitor. Okay.
Yes, sir.
Yeah. Okay. One thing which is not clearly mentioned here is another identical capacitor is connected parallel to the first capacitor, correct?
Yes, sir.
What is not clear in this question? Something is not clear in this question. What is not clear? Usually when you say identical capacitor, what do you understand by that?
The capacitance is equal.
Exactly. So identical capacitor, when I say the dimensions of the capacitor, the material inside, all that is same. So what will remain same in that capacitor is what?
Capacitance.
Capacitance will remain same, exactly. So if the capacitance of the first capacitor was C, now the capacitor that you're going to join here, that also will have a capacitance C. That is very clear. All right.
Yes, sir.
Yes.
What is not clear? Something is not clear. What is not given explicitly? Compared to the previous question something was clear. In this question, it is not clear. What is that which is not clear?
If it's charged or uncharged.
Fantastic, Alvin. Congratulations, right? So in the previous case, it was very clear. What was given? The
Was
first capacitor is a
uncharged.
charged capacitor, and that capacitor is connected to a
Uncharged.
uncharged capacitor. Here it is not given, right? Anyways, I'll tell you in such cases what you should do. Okay, so in our capacitor, first capacitor, what was the charge?
Q.
Q, correct? So let's say it is having some charge on it, right? Okay, this is connected to another identical capacitor. That much is given, correct?
Yes, sir.
When you say identical capacitor, what remains same? Capacitance remains same. Very good, right?
Yes, sir.
Nothing is said about the charge on the second capacitor, correct or not?
Yes, sir.
If nothing is told about the charge on the capacitor, then the charge is taken as 0.
Yes, sir.
Are you clear? So if nothing is told about the charge on the other capacitor, then you take it as it is uncharged. Okay?
Yes, sir.
Yes, life would have been more easier if it was mentioned to you explicitly, but you can consider when it is not mentioned, you take it as what?
Uncharged.
Uncharged. So what is the charge on the second capacitor?
0.
0. Very good. This is the next thing, right? Situation. Now, the moment this happens, what do you expect? What will start happening?
The charge will start sharing.
Very good. Very good. So I was looking for that word, right? So the charge sharing will start now. Until what time or till what point will it be happening?
Till the potential difference becomes the same.
Very good. Very good. The charge sharing will start happening between the capacitors till the potential become not 0, equal. Is it clear? And that potential is called? What is that potential called?
Common potential.
Yes, very good. So it's called the common potential. Okay. These are terminologies which are important, right? Okay. So now let's look into that aspect, okay? Fine. Now, how can you consider these two capacitors as?
Parallel.
Yes, these two capacitors can be considered to be parallel. So two capacitors are connected in parallel. So what will be the effective capacitance?
C1 plus C2.
Yes. So it will be C1 plus C2. What is C1? C. C2 is also C. What will it be now?
2C.
2C, exactly. 2C. Okay. Now, what is the total charge?
Q.
Exactly. Because the other one has 0 charge, correct?
Yes, sir.
So it will be Q itself. Okay. Very good. And what is the potential? Let's take it as common potential. Let's call it as VC. All right.
Yes, sir.
Yes, sir.
So what is the relationship between these three variables? V, Q, C. What is the relationship?
Q is equals to CV.
Yes, Q is equal to CV. So in this case, Q will be equal to what?
2C into V common.
Yeah, let us VC. Okay. Clear?
Yes, sir.
Yes. So what is VC equal to?
Q by 2C.
Yeah, Q by 2C. Okay. Clear?
Yes, sir.
Yes, sir.
So,
Fine. Very good. So now can you tell me what is the final energy stored? So what will be the final energy stored now?
Half CV square.
Half by CV square.
Half into. Okay.
Mm.
Half into C. What is the C here? Okay, C effective into, come on, common potential square. Clear?
Yes, sir.
So what is C effective here?
2C.
2C.
2C. And what is VC?
Q by 2C.
Q by 2C. The
Yes.
whole square.
Q by 2C the whole square. Correct, no?
Yes, sir.
So this can be written as 1 by 2 into 2C into Q square divided by 2C into 2C. Correct?
Yes, sir.
Yes, sir.
So 1 2C I can cancel it. Correct? Clear?
Yes, sir.
Yes. So your U final is going to be equal to Q square divided by what?
4C.
4C. Let me call this as equation 2. Okay, so far clear?
Yes, sir.
Yes, okay. Now let me go to initial equation. Okay. So what is UI? Initial energy? Come on.
Half
Half
CV.
CV square. How can I write it in terms of Q square? Can you tell me how it is? One more formula is there, right?
Q square by 2C.
Exactly. Q square base. Let me call this as equation 1. Okay. Clear?
Yes, sir.
So let me write the equation 1 once again here. Sorry. So what did I have? What did I write? Q square by? Yes.
Q
Yes,
square
sir.
by 2C.
First equation. Clear?
Yes, sir.
Okay. But your initial energy is given as U in the question. Correct or not?
Yes, sir.
Yes. So now what we will do? We will divide both the equations. Two divided by 1. So when I do on the left hand side, it is UF by U. On the right hand side, what is it? Q square by 4C divided by Q square by 2C. Clear?
Yes, sir.
Yes, sir.
So what gets cancelled?
Q
Q
square
square will get cancelled. What will get cancelled?
C.
Yes.
4 and
So UF divided by U will be equal to 1 by 4 divided by 1 by 2. This 2 in the denominator of denominator will come to numerator, correct?
yes, sir.
So it will be 2 by 4. What is 2 by 4? Yes, 1 by 2. So what is your UF equal to? What is the final energy equal to? You take it here. So what is it going to be?
2.
Yes.
U into 1 by
U into 1 by 2, or in other words, U divided by 2. Do we have the option? So what is the right answer?
U by 2.
Option B.
Yes. Is it clear to you?
Yes,
Yes.
sir.
Okay, now one of you can explain. Yes, Akila, can you try the whole thing once again? Even if you make mistakes, it's okay. Yeah,
Yes.
yeah, go ahead.
The energy stored in a charged capacitor is U.
Yeah,
Another identical capacitor is connected parallel to the first capacitor.
correct. So now that is fine. So energy stored in the charge capacitor is U. So can you explain this part of the question now?
Yes, sir.
Yeah. This
So I have
part.
to okay, sir. Now capacitor will take one, sir. Sorry, capacitor will take.
Sorry.
We'll take a capacitor
Okay.
and a battery voltage.
Yeah.
The
Yeah.
battery. Then Q is equals to CV,
Yes.
as we know. U initial is equals to half CV square,
The
sir.
energy stored in the capacitor is going to be equal to,
Half CV square.
or it can also be written as,
Half Q square by C.
yes,
Or
let me take it as equation 1.
yes, sir.
Or half QV. Okay.
Yes, sir.
Fine. Okay. Now what I am doing after this? Disconnecting the battery.
Yes, sir. We are disconnecting the battery. Then
Okay. Even if you
the
disconnect the
charge,
battery, what will be there on the capacitor?
the charge will be shared.
No. First, sharing comes next.
Okay.
What I'm saying is,
The capacitor will be there.
always will be same.
Okay.
What will still remain in the capacitor?
Still remain.
Huh?
Charge, sir.
Charge will remain intact. Clear?
Yes, sir.
Capacitor will always be capacitance C only. Okay.
Yes.
Whether battery connected, not connected, whether charged or not charged, doesn't matter. Okay.
Okay, sir.
Okay. If you connect a battery, it gets charged to value Q. Now, even if you disconnect the battery, charge will still be there on the plates of the capacitor. Okay.
Yes, sir.
That's what I represented here. Okay. Now, this charged capacitor, what you are doing?
So actually, then
Now you read
one.
this.
Okay. Another identical capacitor is connected parallel to the first capacitor.
Yes. Okay. So
After
what are you
disconnecting
doing?
them.
Yes. What are you doing?
Identical capacitor, sir, is connected in parallel. We are
Yeah.
This is connected in parallel.
Okay. Identical capacitor means what? Identical means looking
Same.
like. Yes. They say identical twins. Correct.
Yes, sir.
Yeah. Looking like same. Right? Looking same means what? What is same in that capacitor?
Charge is.
See, a charge is like the rank that a person has scored. Okay.
Yes, sir.
For example, okay, exam was conducted, rank was stored. Identical twins will not have. If we say the these two people are identical, what is the meaning? They look similar. Their body is. You get my point?
Yes, sir. Yes,
Their
sir.
face looks similar. That doesn't mean their rank is same. Understood?
Yes, sir.
Okay, so identical capacitor means what?
When the voltage.
No voltage, no charge, nothing. Okay.
Capacity.
The physical appearance will be same. Physical appearance means area will be same. Distance between the plates will be same. The medium inside will be same. So that will only correspond to the capacitance. Only you can say C is same.
Oh, the capacitor is same.
Capacitance of the capacitor will be same. That's all
Same.
identical means.
Yes, sir. Yes.
Nothing else you know. Okay.
Yes, sir. Sorry,
You
sir.
don't know about the charge. You don't know about the potential. Okay.
Yes.
Clear? They are like rank and maybe blood. I don't know about biology students to help me. Okay, fine. Are you able to understand the point?
Yes, sir. Yes, sir.
Identical capacitor means what?
Sir?
When I say identical capacitor, what is the meaning?
The capacitance of the capacitor will be same.
Yes, capacitance of that capacitor will be same as the other capacitor. Clear?
Yes, sir.
Okay, done. Here nothing is given about the charge. If nothing is told about the charge, what you will take the charge on the capacitor as?
0.
0. Okay, uncharged, you will consider it as an uncharged.
Uncharged. Yes, sir.
Okay, fine. Yeah, now go ahead. Now proceed.
The uncharged will be 0.
Yes.
And then it is when that is uncharged also, the charge will be sharing.
Yes, one is uncharged, one is having charge.
One is having
so when
charge.
you are going to connect them, there will be charge sharing.
Charged share. Yes, sir.
Correct. Okay, go ahead. So till what point the charge will be shared?
Potential difference. Till the potential difference.
Till the potential difference becomes equal
Equal
across
in-
both capacitors. Clear?
Yes, sir.
Okay. Fine now.
Then we get common
No,
potential.
let's go step by step. Okay. First is this one. Next.
Yes, sir.
So these two capacitors can be considered to be?
1 second, sir.
No problem. We are just spending a little time so that it becomes absolutely clear
Yes.
to everybody. Okay, go ahead.
Yes, sir.
How are these two capacitors connected, Ma?
Parallel.
So what is the effective capacitance?
2C, sir.
2C, very
C1 plus
good.
C2.
Very good, Ma. Very good. And what is the total charge?
Q, sir.
Q plus 0, correct?
C, yes, C.
That will be Q. Very good.
Q.
Now, what will be the common potential? What is the relationship between common potential Q and the charge capacitance?
Q is equals to CB.
Normally CV, but here what is C?
2C into VC.
Very good, ma'am. Very good, very good. So what is potential?
So,
What is
common
VC?
VC is equals to Q by 2C.
Very good. Okay, so far clear?
Yes, sir.
Now we have to find out the final energy.
Final
energy formula.
Half VC square.
Yeah, half CV square. Half CV square.
Yes, sir. CV square.
What is C here?
2C.
Yeah, what is V here?
Q by 2C.
Yeah, whole square. So when you simplify, you will get Q square by 4C. Okay.
Yes, sir.
Initially, only we got for the initial energy, what is it?
Q square by 2C we got.
Yeah, so when you divide both of them, what do you get?
You final will get half
U.
1 by 2
Yes.
was
Very good.
U by 2.
Yes,
We'll
U by
get
2.
as U
That
by
is what
2.
is asked in the question, and that is the answer. Okay.
Yes, sir.
So are you all clear with this? Are you clear, Akila?
Yes, sir. Thank you, sir.
Okay, ma'am. What about Rahil, Rebecca, Alvin?
Yeah, sir.
Yes, sir.
Yeah, I'll just give you a minute to take it down if you have not taken it down already. I'll just give you a minute. So this question we will be completing the class. Okay. Once you've taken it down, tell me, then I'll move the slide.
Done, sir.
Done, ma? Okay, great. Please take down the next one.
Done, sir.
Done, ma? Okay. Then last.
Done, sir.
Done, ma? Excellent, excellent. Okay, good. Okay, students, all the best. So you're getting better and better in the topic. Okay,
Yes.
so please practice. All the questions which we have done are very, very important types. Please do them again, review them again, do them again. And the link of this session also I will upload and I will send it to you. Go through this lecture once again so that you are very comfortable. Already I'm confident that you are getting better, but not only understanding will be sufficient, but practicing these questions again will be very important. All right.
Yes, sir.
Yes, yes, yes. Once or twice, once you listen to this lecture once again, and then you practice once or twice, then the concept will get into your you very comfortably. Then speed will automatically increase. All right. Don't worry about your present speed, but it will increase once your understanding is enhanced and you become expert. You are very confident. Now, any answer you are answering right now, you are like saying, as a doubt, right? But once you are very comfortable, then you'll be confidently answering. So once you reach that stage, right, that will only happen after practicing and reviewing this video once or twice. Okay.
Yes.
Yeah, do that. Find some time for doing this, and then you will be very good. So next week again, we'll be continuing, and we will hope to complete capacitors by next week, and then we'll proceed to electricity. All right.
Okay, sir.
Okay, electricity and the remaining part of electrostatics also we can do it. Fine. Next week we'll also be
Yes,
having
sir.
mathematics class. Yeah. Take care, guys. All the best. See you all. Have a good weekend.
Thank you, sir.
Bye.
Thank you, sir.
All the
Bye,
best.
sir.
Bye. Take care. Bye.